Go ahead and hide that pod.
Okay.
There's your audio. I can hear you just fine. Go ahead and see if you can bring your video up. It should be, it might try and bring you. There you are. You look good. Very cool. Right. Like the little CF logo there in the background. Nice touch.
Little Adobe one too.
Love it. Love it. All right. All right. Well, you sound good. You look good. We're ready to go. I'm going to drop you into your talk here. Hopefully things load properly. We're having some issues with our media server still. It looks like the top is also failing to load for me, so I'm going to go ahead and hide that. You should have a screen share on the left top of your screen share. You should be able to get that in there, and I will let you know if I can see it. Right now, it's just black. Go ahead and just going to make you share the whole darn thing. All right.
What?
Got a square with an X on it that I'm seeing for you.
What screen is it showing? Can you see?
I'm seeing a black screen, and there's like a little white outline with an X in the upper right.
All right, it did not preview for me, so I had to guess my way through and got the wrong one.
Sorry about that.
Screen, third monitor. All right, how about that one?
Exploring AWS Java SDK developer features using CFJava. Awesome. All right, take it away.
All right. Well, thank you, Mark. Thank you, everybody, for joining. I want to personally thank Adobe for inviting me to speak today. And this presentation is talking about the AWS Java SDK, and it's going to be utilizing the new CFJava features that came available in ColdFusion 2021. And the goal is there's some CFC modules that are going to be available. I'm going to speak to that in a second, but the goal is to hit 99% use case for what most of you can use out of the box very simply without getting into too much detail. And so in this, we're going to be also, I'm going to talk about how we will be providing access to this code shared in the presentation and to additional information about each module in an upcoming blog post on the ColdFusion community portal. So keep an eye out if you're looking for details on that. All right, so a little bit about us. We're Coalesce. We've been working with ColdFusion for a long time. We specialize in high compliance environments, HIPAA, PCI, FISMA. We're the Adobe preferred vendor for migrating workloads to AWS. And we've been working with our clients for quite a while, and we're happy to help them grow with us. And I'm going to go very quick through all this because there's a lot of content to cover. And I want to try and be as succinct as possible, yet cover everything as I can. So just to give you an overview of what we're going to be talking about, there's a bit of a getting started in this presentation. And hopefully, if you've not seen this, you'll at least know how to get everything connected and get going by yourself. If you have seen this, then just be patient. We'll get to the rest of the topics. So we're going to introduce you to CFJava, the SDK. We're going to go over the parameter store, the secrets manager, the key management, some metric reporting, and we're going to conclude with the Q&A. And the person with the best question gets an MX voucher. So save your questions and feel free to ask. All right. So what I want to start with is what we are not going to talk about. We're not going to talk about the cloud native features that are now available in ColdFusion 2021. This is things like the storage in S3, the NoSQL databases on Dynamo, and the message queues and delivery and the SQS and SNS. And for each of those, you don't need an SDK. And that's great. But for the things you do need an SDK, there's a bit of a prep work, and there's a lot of power behind what you can have available to you once you implement it. So I'm going to start with the first part of the prerequisites. You got to get yourself an AWS account. Then once you have your AWS account, you need to create your user account or role in the IAM, the Identity and Access Management portion of the AWS console. And last, you need to download the SDK. Make sure you get version 1. Version 2 is made for those of us that are, I don't include myself in that us, those of us that are able to compile Java classes with Maven. And that would be its own presentation if we want to go down that pipeline. So version 1 SDK, please. All right. Another prerequisite, getting your SDK loaded into ColdFusion. You've got 2 options. You can move the jar files. There's a primary jar file with all the objects in it that's provided by the SDK, and a third-party folder that are the dependencies that jar file depends on. An easy way to do it is just to drop all those files into your ColdFusion class path, for example, the cfusion/lib folder, and then restart ColdFusion, and voila, you have access to the Java objects. Option 2, you can use the CFJava loader, which would be my preference. In this case, you copy those same jar files to a folder. It can be in the same path as your application is, or it could be outside of your application path. And to load those jar files, you use the this.java settings in your application.cfc, similar to what I have here. In this case, you're telling it where the jar files are, and I went ahead and provided the reload on change true, because if you're developing, you want to be able to tweak things and change things, and you may forget a file or replace a file. So in the demos today, option 2 is what I've done. So going along with the line of things that I will not be telling you, I'm not going to show you how to log into AWS SDK using your access key and secret key directly in the code. This is something you want to avoid like the plague. You don't want your credentials in your code, and so you're going to find that missing in what I'm showing you today. All right. Still going on prerequisites. So every access call to the SDK has to be authenticated. And there are 4 ways to provide your credentials for the AWS IAM role that we created in the earlier steps. If you're running on AWS, which is option 1, you can assign an instance role, task role, or execution role, and the SDK inspects the current running environment and automatically pulls and utilizes the role that you have assigned to that compute unit. That's very easy. You don't have to do anything at all to your credentials. They don't need to store it anywhere to make that work. Second option, the Java system properties. So in your jvm.config or in your ColdFusion admin, you can add more JVM arguments. Just add a -d AWS.access key ID with your access key, and the same thing for your secret key. Restart ColdFusion, and the SDK will see that in your Java environment, and it will automatically use it. If you want to go down the credentials file route, if any of you have used the AWS CLI, you'll know that there is a credentials file that is used. If your ColdFusion service is running as a specific service account, you can load a credentials file into that folder, the home folder of that account, and that is another way. And last but not least, the environment variables. You can define environment variables as defined here, and again, the SDK will see those. So these are the 4 ways, and this is usually the first struggle, is how do you get authenticated without having your access key and security key in your CFM or CFC code. And these are the 4 ways that I've been able to identify and document. All right. Now a little quick intro to CFJava. So there's 2 different ways to do this. You have the tag base and the CF script. And in either of these cases, ColdFusion 2021 made it so easy to use Java now. So instead of having your Java line by line, building your Java objects and communicating in line with Java, you can have a full set of Java code native just directly embedded within the CFJava tags. And after you've created the Java class with your raw Java code, you can just access it like any other Java object you've had loaded in memory. Same thing with CF script. It's just into Java with an open brace, curly bracket with your Java code, and then same way you can use it. It's not really that difficult. It's just a little bit of a getting used to kind of situation. All right, so this is when we start getting a little complicated, but the overall goal of this page is to give you the idea of how the SDK works. So every single AWS service, whether it's Systems Manager like this, DynamoDB, S3, so on and so forth, has a client. And in this case, you have a client builder that you then do the build function. And when you call the build function, it does the authentication. And out of that, you get your authenticated client. And that client is then how you communicate further with that service. So in this example, we have the authenticated client and we have a get parameter. And instead of passing something directly to it, we have to build a request object, pass into the get parameter function, and we get a get parameter result object out of it. Same thing for the put. And this is very similar for all AWS SDK functions. And once you've gotten one down, the rest are kind of much easier to implement. And I included this quote down at the bottom. When you've created your client object that's authenticated with AWS, they are thread safe, and you should treat them as long-lived objects. So store them somewhere in your server memory if you're going to be repeatedly using it. And it has its own connection pooling. And when you're done with it, be sure to shut it down. But overall, what I've learned is if you build it every time you use it, you're going to be slowing your whole application down, because during that authentication, there's a lot of handshaking going on. And if you have to authenticate every time you make a call, you're adding 1 to 2 seconds for every request versus, the get parameter should happen in under 100 milliseconds if you have a good connection. All right, so on to the first AWS service, the Systems Manager. So System Manager has a variety of features to help you with your applications infrastructure in AWS, but I'm going to focus on the parameter store. This is something I wish I've had all along when developing in ColdFusion, because you have different environments. How do you get environment variables in, and a variety of other things you want to store separate from your application server? Parameter store is a great place to do that. And from there, we're going to break out and take a quick look at the code. All right, so I've got a SSM CFC file. And in this case, we've got a function that we created called getClient, because remember, we're just trying to authenticate and get the classes that we want out of this. So we have the new CFJava logic. We've got some raw Java code all the way in this section here. And in this, we have a constructor where we actually do the build. So in this case, this is the bare minimum you need to create your client to actually have access to the SSM client. I've got a couple parameters. I got a couple functions in here that we put in to make it easier to call these. We've got two that we're using right now, called get parameter and put parameter. And all it takes is a parameter name, and we get a string back. It's really complicated stuff. So I'm not going to go through every line, but the idea is we prepare the request. We actually do the call to AWS, and then we return the string back. And same thing for the put. With the put parameter, we have the put parameter request, where we tell it to go ahead and overwrite. We store it as a secure string, which by default encrypts it, and with the new value. And then we end up sending that request on AWS. It's quite simple little solution. And to use it, our CFM file loads our AWS SSM CFC. We call the get client with the region number we want to, region name we want to use. And then we replace a parameter, and we're going to put a timestamp in there so we know it's changed. And then we're going to pull it immediately and dump it to the screen. So I just called this. It is currently 1:45 my time. So in this case, it replaced the demo parameter and retrieved it and dumped it to the screen. And I can show it to you in the AWS console. In here, I've got 2 parameters in my parameter store in the systems manager. We're going to get to this one. The demo parameter, we can see it was modified today. We can see that. We can go through a history and see how many times it was changed. There's a lot of power behind all of these features in AWS, and this is a great, simple one that I recommend you using. So that was a quick breakout, and I'm going to jump into how can I use this? There's a lot of ways to use this. I put a number of examples on the screen here. You can store your environment variables. So if you have a different operating environment for production versus development or testing, you can store a variety of things specific to those environments in the parameter store. If you have credentials, say you need to log into something third party, you store it in parameter store. And that way there's no local credentials stored on your ColdFusion server. It just loads in memory on start. This is a great way to do it. If you need to have endpoints, you can put URLs in there that you need to access. If you have client keys, if you have a server state, let's say you have a job and you want to remember where you left off at last time, you can store that ID on the server state. Another way to do it is for data source definitions. I like the idea of storing my data sources for each environment in there so that on server start, it can pull down and load in the data sources. This way, your server definitions can be consistent between each environment, but the parameters make it very easy, the parameter store. So overall, anything you want to be exposed publicly in case your code gets accessed or your server gets taken over, this is a great way to store it. Next, this was going to be very quick, the secrets manager. So the secrets manager stores your secrets with an option of automating the secret rotation. And it's very similar to parameter store. And I'll show you how we can use it very quickly. And we're going to break out real quick to this. I'm actually using the parameter store to pull the secrets. So the same CFC we had before, I've created a function called getSecret, and I've prepended it with this static prefix /AWS/reference/secrets manager. This is assigned to AWS that you're trying to pull a secret value. So in this case, I'm treating it like a parameter, and I'm just going to go pull that value. And let me go back here, call secrets, and bam, there's my secret value, which is stored in a key value pair, where my super secret is not so secret anymore because I just showed everybody my secret. And just like the parameter store, I can view my secrets in AWS. By default, it doesn't display it to the screen because it's supposed to be secret. And you've got a bunch of other options for the secrets manager, which I'm going to jump into why that's important and how you can use it. Somebody's trying to hack me. That'll be fun. Okay, so secrets manager. Some of the fun things about secrets manager is it helps you with compliance. So if you have a high level compliance where you have to automate your database rotation of your credentials, that's where secrets manager come into play. So secrets manager already is baked in to support a lot of Amazon database services, including RDS, and it can rotate your database password. And with that, it can trigger a Lambda that you can then signal to your ColdFusion application that the password has changed, thus completing the rotation. So that Lambda fires, it calls your ColdFusion app, which then goes and fetches the latest secret, which updates the DSN. That's kind of the overall flow. So 99% of the time, the parameter store should work for you. Secrets Manager gives you a little bit more power when you have something like this, whereas you have higher compliance requirements. All right, time to get a little bit more detailed. So the key management service, this is one of my favorite because it solves problems that I couldn't solve without having physical hardware on site. So the key management service is a way to have your own hardware security module to protect your encryption keys and to encrypt, decrypt those things. And I've got two examples of how you can use this. I'm keeping it simple here for the first round. With AWS KMS, Key Management Service, you've got your KMS key that you create. So your encryption key is then managed by KMS. And the KMS client has an encrypt and decrypt function that's available to it. And every time you call these encrypt and decrypt functions, every access is logged in the AWS CloudTrail, which is an immutable log. It cannot be changed. And it basically certifies every encrypt, decrypt action that has occurred. So on to the simple KMS example. The CFC is not so simple. There's a lot of fun with KMS in terms of dealing with your decoding, base 64 decoding, dealing with the encryption types, some character car sets, fun trying to make this work. But overall, I want to just kind of highlight the key points. So the exact same.
Hey, Brian, sorry to interrupt. Could you make the text on this just a bit bigger? Some folks are on like kind of crazy screens. So if you could, awesome. Oh, that's beautiful. Thank you so much. Appreciate it.
Good point. Sorry about that.
No problem. No problem.
All right. So in this case, we have the same kind of format. We've got our get client. We've got our Java, CFJava open here, and we have the raw Java code inside. We have our builder where we actually do our authentication and get it back. And we've got some functions that we've created to help us do the encrypt and decrypt. So we're encrypting with a plain text, our key, a thing called encryption context, which I will get into. We have a decrypt and some other functions to help us along the way, which I'm not going to go in until we get to that point. So it's the same kind of overall flow of creating the client, doing the connection, and then accessing it with ways that make sense for us. By us, I mean me, and I'm interpreting what you could do with it. And you can obviously take this code and expand upon it. All right. So for KMS, for us to utilize this CFC, we create our object for KMS. I'm going to go ahead and use the SSM object we used earlier. And I'm using the SSM object because I want to get the parameter that stores our KMS key ID. Again, this is just so that I didn't have to store my unique key in the source code. And I was going to just show you that real quick. Parameter store, my demo KMS key. So my demo KMS key is just a access reference for AWS to my key. And so now that string stores that key that we got from the parameter store. I'm creating a string that I'm going to be encrypting. I'm doing the encryption, and then I'm decrypting it immediately afterward to prove that this is a symmetrical encryption. So demo text encrypt was the quick brown fox. Here's what the encrypted value of it looks like. And then we decrypted it back to the way it was. just proving that this flow works. I mean, overall, creating this CFC is a great example of how all of this fun mess of code to handle all of this type of encryption and dealing with binaries and such can be shrunken down to literally 2 lines of code to do an encryption. So the goal is to show you how easy it can be. So speaking of easy, let's talk about hard. I'm going to talk about two new topics that related to encryption. A data key is the first, and this is a way for you to, let me just take a step back. You can request a data key from KMS. And when you do, you'll get an encrypted version of it and a decrypted version of it. And then you can use that key to then encrypt with the native ColdFusion encrypt function. At the same time, you can decrypt with the native ColdFusion function utilizing that data key. And then your future use of that data key, you can decrypt it using the KMS decrypt functions from before. And it'll make more sense as I proceed. I kind of butchered this, but we'll keep going forward. Another topic I want to introduce is the concept of encryption context. And I put this quote up here at the top to kind of help me describe this as best as I can, because there's some corporate keywords that you may want to hear. The encryption context is a optional set of key value pairs for contextual information about the data you're encrypting. And it is used as additional authentication data, AAD, to support authenticated encryption. And in a nutshell, description of that is, it's a structure of key value pairs that must match during both encryption and decryption. So this is how it gets more complicated. So let's go through this example, and then we'll go into the code, and then you'll see how straightforward it actually is. But I wanted to kind of show the overall picture of this flow. So the same kind of situation we have here, your KMS key is in AWS, and you're going to render a data key from the SDK. And out of that generate data key, you get two values. You get a cipher, so an encrypted version of that data key, which you then store somewhere, let's say in your database, and you get a plain text version that you then can use as part of your encrypt and decrypt with ColdFusion. Let's say later on you need to decrypt something you encrypt with that data key. You're going to retrieve the cipher from your database. You're going to decrypt it using the decrypt client from KMS. You're going to get your data key plain text back, and then you can use your ColdFusion native functions with that plain text just as normal. So that's the overall flow of this whole data key situation. You can have a data key per record, or you can have one central data key. It's up to you and your application and your requirements. But this is the overall flow of that. So I'll show you how easy this hard version can be. So we're going to start the same way. We have the two clients. We're going to get our key from AWS, from the parameter store. We have the string we're going to encrypt. I built a structure of key value pairs of my business logic. Let's say my tenant ID 123, and this is transaction ID 345. So this is the context that must match both when I encrypt and decrypt going forward, and you'll see why. So we're going to generate a data key, and we're going to get a struct out of that generate data key function, because that's the way I wrote it. And I will show you that real quick. There, generate data key. So in this case, just so everybody can enjoy this, a Java map string is the same thing as a key value pair structure. So in this, we generate our request for generating the data key. If we pass an encryption context, we use that. There's a key spec that we provided as well. We actually send the request to generate the data key with the parameters that we defined above. we add this little step here to simplify the conversion of dealing with the encoding of your data keys. Both the cipher and the plain text have their own fun of interpreting all that. And from there, we return our struct back to the CFM. So CFC is doing a lot of the heavy lifting. Overall, one-liner, very easy to implement now. So we're going to generate a data key. We get a struct back. Next, we're going to use the ColdFusion encrypt function using our plain text data key that came out from KMS. And then later on, we're going to act like this is kind of our break in the line here. We want to decrypt this value again. So we're going to act like we have the data key the data key ciphertext that we stored in a database. We need to decrypt the data key using the decrypt data key function that we created. And it will decrypt that. And then we can use that new key that we just got from this decryption in our ColdFusion decrypt to decrypt the value. It's a fun little dance, but it's very powerful because it now requires a business logic context to match to be able to access your data key. You're encrypting locally and decrypting locally, which may increase your throughput. And again, the encryption context is required when you decrypt the data key, which basically says, even if somebody had access to your key ID, has access to the data key, if they don't know your encryption context, they still can't decrypt the data key for use. So let's just take a quick look at what that looks like. Voila. We generate a data key cipher. Here's a plain text we got back. We went ahead and did the local encryption of the demo text. This is what that looks like. And then later on, we decrypted the data key from the cipher we received, which, yes, we can see it matches the original plain text we received. And last but not least, we decrypted the text using the data key, and we dumped it back to the screen. So we did a full circle here of encryption, decryption with this data key. And one of the things I wanted to point out, and I'm going to jump over to the AWS console, is the usefulness of KMS is in its audit logs. So my session expired. Give me 1 second. All right, I'm in the AWS CloudTrail, which is where, and I'll go ahead and zoom in so everybody can read, where every AWS SDK or AWS CLI or console action is logged. And you can see that my demo did a decrypt. I'm going to click on it, and I can see a lot of details about the actual action that occurred. And you can see that we did a decrypt. There's a encryption context where what the encryption context was, which looks like I have a bug, but I'll look into that later because, you know, live testing is great for things to work every time you want it to. So anyways, a lot of the power behind KMS is the CloudTrail logs. So if you have a data key and you think it got exposed, they need a login to your AWS console that has access to that KMS key. And then once they use it, it's going to show up in this log. So you can be very certain of use of your data keys using this AWS KMS. All right, so let's move along. All right, so KMS versus handling encryption keys yourself. The typical answer for everything I say is compliance requirements. Some high security compliance requirements require a hardware key manager, and that's what KMS can provide. All the access logs. So everything that's done within KMS is logged. The KMS will also automate your key rotation. So basically, after a key has existed for 6 months, it'll rotate to a new value. The old one must still be able to be used for decryption, but it no longer can be used for further encryption. And it's all handled automatically without you having to do anything. And last but not least, the KMS gives you options for more high security encryption techniques. So if you want to have a distinct encryption key for every single transaction or record in your database, you can do that. You can generate a data key, encrypt, and store your data key along with your encrypted value. And that means if one data key is exposed, you get only access to that one record. It reduces your the scope of possible issues of being hacked and what they can get access to. All right, so I'm going to provide another quote at the bottom of the screen from the documentation. So the KMS client, encrypt and decrypt, is made for encrypting and decrypting the data keys. You can use the encrypt and decrypt for your application, but it cannot be more than 4 kilobytes of data, and it's not meant to encrypt your application data as a whole. So your results may vary. Your application may have various requirements, but if you want something to log every single action, the KMS provided encrypt and decrypt can solve some problems for you without you having to over-engineer things. Okay, so the last AWS service I'm going to go over for SDK is CloudWatch. This is a tool within AWS that you can use to monitor a lot of things. It's got a lot of metrics. Like out of the box, CloudWatch is used for your cloud usage. It'll show you how many instances you have running. It'll show you a variety of things about your requests. Almost every single AWS service logs some kind of metric in the CloudWatch. And you can log your own custom metrics, which is what we're going to go over. And I wish I had this a long time ago, personally. Okay, CloudWatch. Same kind of flow here. We have our client. We have our Java code. We do our build, which does the authentication. We get our CloudWatch client back. And we've got one function we're using here, put metric. A metric includes a dimension with its own name and value, your datums, which includes your unit type and the metric value of the measurement. And I'll go over that in a second. You'll see in the example, it makes more sense. And then you have the overall metric request that you push to AWS using the datum and the dimension from above. So this is the high-level view of how you put a metric in place, and I will show you how we use it. I've got a little function here, a little CFM here, where we create the client. We're creating a random number between 1 and 20 for how many times we want to create sample metrics to report. I went ahead and created this 4-tier stack of app name, service topic, and metric name to give you an idea of how you would arrange your different data types. So let's say you have your app name, my important app, service name I want to log because this is metrics. This is my outgoing payments. Let's say I'm sending money to a payment provider. And I've got different payment providers, so my topic is payment provider 1. And the metric I'm recording is request time. So I'm going to put my metric, including my service name, my app, my topic, and this is the metric I've got here that I'm putting, and I'm putting a number between 0 and 10 seconds in the CloudWatch. And to give you a quick example of that, this is very fancy stuff here. Bam, I just logged 6 metrics into CloudWatch. And this is not the interesting side. The interesting side is in CloudWatch itself. And I've got a little bit prepped here for displaying. All right, so over the last 3 hours, I've been randomly hitting that page to generate some sample CloudWatch metrics. And I've brought up the minimum, maximum, average, and sample count. Each of these has their appropriate color code here. And the fun thing is you can actually set alarms on these. So let's say you're recording your request time and you start to see it creep up. You're like, okay, you know what? I need to set an alarm for when the average request time is over X milliseconds, something like that. So I can set up an alarm in CloudWatch to trigger. And that alarm can do a variety of things because AWS uses CloudWatch alarms you can trigger an SNS, you can trigger it to go to the SQS in a variety of ways. You can even have SNS launch an HTTP endpoint. So you can have your CloudWatch alarm to be triggered and do things. This is how you can automate issues with your application. If nothing else, you can have it ding you with an SMS on your phone saying, oh, we're getting to be unhealthy. You need to start logging in and looking at things. So CloudWatch metrics is pretty neat. And I wish I had this for all my apps in the past. But this is something that you can use to keep an eye on the health of your system. So got some examples for how you can use it. If you need to track your system load, let's say you need to send a signal. So you can just even send a signal to CloudWatch with one sample, and it starts to trigger something. So, I mean, you would use SNS for that, but I'm giving you examples. So let's say you're sending metrics, and you can say, based on this type of scenario that comes through, we want to create a metric-based alarm. It could be based on a sum, a min, max, average, a variety of things over some duration of time. So CloudWatch can help you keep track of your application. So there's a lot to AWS SDK, and this is the end of my presentation. I'm gonna wrap up by talking about what else you can do. This is just a sample of 12 that you may want to look at. You may have fun trying out. It ranges from text recognition to doing some machine learning forecasting. Kinesis data streams is a great way to stream data from, let's say, a log stream into ColdFusion if you need to parse your logs. They've got their own location service for GPS coordinates and such. They've got other databases like their Quantum Ledger database, and they've got a blockchain you can manage this as well. So the SDK can give you access to all of these features. And hopefully with what I've described to you, and when you get access to the code in the blog post we'll be doing, you can expand what we've done into other things you want to try out yourself. So with that, now it's on to questions. If you have any questions, please type it and we will read it. If you have anything you want to ask us after this, you can reach out to us at cf@coldsolutions.com. Our website is coldsolutions.com. And if you want to get your ColdFusion license on AWS, we have a variety of ColdFusion servers listed on Marketplace. You can pay by the hour, or you can reach us directly at cf@coldsolutions if you need to buy outside of AWS or have questions about AWS. But that's the end of my presentation. I saw a bunch of chats as I was talking, so let me see if I can catch up to that.
Awesome. Thank you so much, Brian. Yeah, we've got, so we have a Q&A pod, and that has got some questions in it. And I think most of the questions ended up in there. I think Greg there at the end had a question about the latest CF exception that you had shown there and how it showed up in CloudWatch. I think that ended up in just general chat.
So I don't remember getting a CF exception. I think I was saying that if you had an exception to your logic of your business logic, you can send stuff to CloudWatch. I'm not exactly sure what exception it was you were talking about.
Oh, I asked because you mentioned server logs and CloudWatch for the AWS SDK. May have misheard. Okay. Oh, I think it was just a misunderstanding. AE asked, can I use AWS SDK like code commit to CF and auto deployments?
Absolutely. We use that for our static EC2 instances. So we commit code into AWS code commit, which triggers a code pipeline, which ends up pushing code to our production servers or whichever environment we're in at the time to our servers directly. And it's a very powerful and neat little service you can provide, because you can also put together a approval step in the code pipeline if you need somebody to have extra authority to approve a push. So yes, there's a lot of solutions for that, and it is all available on AWS.
Very, very, very nice. So early on in your talk, Charles T asked, can we get this source code on GitHub, which I think was referencing some of your demo code that you had going early on. And so I think just wondering if you've got a GitHub repo that people could look at for examples.
So if somebody wants this and they want to get access to it early, you can just reach out to us in our email address, and we will see about sending out that code. But you will be able to get access to this code in the ColdFusion community, because we are going to do a forum post for each of these and further elaborate on them. And we would love any feedback you have. This is obviously just a start, but hopefully it can be very useful for your projects as they are.
Very, very cool. Had another question from A. Can we via SDK with the ColdFusion code generate secrets remotely from the same CF code? I think I understand that.
Sorry, could you repeat the question?
Is it possible? So it sounds like I'm trying to get the grammar here. Can we via the SDK with ColdFusion code generate secrets remotely from that same CF code?
So I didn't provide the method to replace secrets because they're supposed to be replaced programmatically by AWS in a rotation. Mm-hmm. So if you need to create your first one, you can do it manually. But after that, you should only be consuming the secret, and you can pull that from 50 different servers placed all over the world if you need to. That's the best part of this.
Makes sense. Makes sense. I actually had a question in here. I was just wondering, what kind of overhead does KMS add to an application when you're doing a lot of like authentication across? Are there any latency issues, anything like that, scaling issues that you have to worry about?
I have not run into any. So using the concept of storing the SDK client in like the application scope, we've been using KMS for a good 6+ years, and it has never been the bottleneck of our application. So we have thrown probably thousands of records at a time into KMS, and it never has caused us problems.
Fantastic. This one, I don't even know. I don't really want to read this one out, Greg. Can you read the Q&A pod there, Brian? Can you see that okay? Greg asked if you can ever use the underlying Java from a CF query to find an exact volume in a column. And then, my gosh, that's a lot of code. Get metadata, my query slug, index of, something along those lines. I am not sure exactly.
I guess so. Maybe I have to stop sharing to see the Q&A.
Possibly.
Oh, there we go. Now I can see it.
There you go.
Okay.
And we're all kind of down towards the bottom. Greg had a little bit.
Yeah, I don't think I've ever done it that way. I don't know if I have experience without testing it myself, so I don't think I can answer that question.
Gotcha. Let's see. I think that's most of. Oh, here's one. Have you ever tried tracking JRun performance metrics in CloudWatch? That was one that Greg asked earlier.
I have not. I don't know how I would send the JRun metrics to it. Maybe you have a cron job where you're taking a sample of it and you're throwing it to the AWS CLI. But no, I've not inspected the JRun performance that way.
Gotcha. Okay. Greg just had another, curious how it would compare to New Relic 1. I use the Java APM to monitor CF apps with amazing detail without having to touch a line of code or the JVM.
So I look at the CloudWatch metric, the custom CloudWatch metrics, to be more your business logic you're monitoring, not the application server. So things like New Relic and other tools that log your memory usage and other hardware-based or request-based activity, the custom CloudWatch metrics may make more sense to your business. So that's why I put in there some third-party provider. If they ever start slowing down, it's going to impact your customers' response time. And that metric is not something you will find out of the box with a monitoring service.
Are there cost issues also that you may run into overusing something like a CloudWatch? I think I've heard stories, like horror stories, of people, waking up to a $20,000 monthly bill because their CloudWatch was literally just monitoring every single bit of data.
Yeah, so you don't want to spam it nonstop. I personally run into monitoring tools that get metrics nonstop across multiple accounts, and it did add up to a few $100s in 1 month. But that's a good point, and I think that is a good example of if you have a high volume traffic application, you probably need to consider choosing wisely how often you push metrics. Now, typically a lot of AWS fees and things like metrics and KMS and so on and so forth, they charge you for the, per 10,000 requests or something like that. So you have to be fairly high volume before you start to see a blip in your bill.
That makes sense. Yeah. AWS is pretty good too about warning you ahead of time, unless you turn those warnings off, which some people have in the past. Awesome. Well, I think that may have handled all of the questions that I've seen. Thank you so much for this talk, Brian. This was amazing. So much info. I'm gonna have to rewatch it.
Yeah, this was a bit much of content. I actually had more, and I had to trim it back. I would love to do more deep dive on KMS alone, because you don't want to mess up your encryption, and some of these things could be a deeper dive specifically only on one of these topics. And it was nice to be able to just go over at a high level. Here's how you can use it very quickly, and I'm going to give you some tools of how you can do it.
Fantastic. And you have, of course, submitted those deep dive topics for a CF Summit talk in Vegas later this year, right? That's on.
Not yet. I'm curious of the interest in that, because it may be too few people may be interested in it. I want to help as many people as I can.
Makes sense. Yeah. I know encryption is always a very interesting topic for folks, and especially when you're talking about the cloud. I think that's something that people don't quite intrinsically get. And so having an expert coming in and kind of showing them standards-based stuff is fantastic and hugely valuable. So we'll chat.
All right, perfect. Well, thank you everybody for joining, and I appreciate you taking the time to watch, and enjoy the rest of the Developer Summit this year.
Thank you again, Brian. I'm going to move us to the outro. And if everyone could, please give us some votes on Brian's talk. Hopefully you enjoyed it as much as I did. These polls are very important. Definitely want to have as many of you voting as possible, and let us know. That is it for today in terms of speakers. Join us again tomorrow morning. Well, depends where you are on the planet, but for me, it's super early morning when we have our own product manager, Aditya Nima, talking about using ColdFusion to build internal apps. That's coming up in, oh gosh, many hours, I guess, but it'll be tomorrow morning for me. Thanks again. And then we will be shutting down the session to do nightly maintenance in a few hours. So definitely don't have your speakers on full, because I will probably terrify you when I make that announcement. Thanks again for coming today, and I'll see you all tomorrow.